that PAL stands for Personalized Learning, Adaptive Learning, right? And in a typical classroom where a teacher teaches about 30-40 students, the teacher generally finds it hard to attend to the needs or even engage the needs of each and every student and then cater to it. Research also shows that, and if you look at Professor Bloom's research, it also shows that there are, when you compare different methods of teaching learning, namely the lecture method, which is a typical classroom, the mastery learning method, the individual tutoring method, research shows that the individual tutoring method has much better learning outcome as compared to the other methods, right? So PAL is all about how we can adapt to the student's current level of learning and how can we help the student move ahead on that learning journey. So in an individual tutoring, a teacher is attending to one student at a time. The teacher is engaging continuously with the student, trying to understand what is the student knowing today, currently on this particular topic, and then giving instructions to the student for the student to continue on his or her learning journey, right? This allows for the teacher to adapt her instruction to the current level of the student as compared to having the instruction at the average level of the classroom. Now let's look at this from with an example in mind, right? And let's take maths. Let's take decimals as a topic, right? When students are in middle school, decimals is a topic that they learn. They learn amongst a variety of things that they learn in decimals. Comparing to decimal numbers is one of the concepts that they learn. Right. Now, what research also shows us, this is based on research from Professor K. Stacey from University of Melbourne, is there are lots of different ways in which students think when they're comparing decimals. And we will, talk about this through an example. So when we ask students to compare two decimal numbers, 3.27 and 3.3, and ask them which is the larger number. Now, we know that the correct answer is 3.3, but there were students who said 3.27 is the larger number. And when students were saying this, they were looking at the number as a whole number, 327, and the other number as 33. And of course, 327 then becomes a larger number. Now, this is what research calls as whole number thinking. When you give them another pair of decimals, say this time 3.27 and 3.18, right? We know 3.27 is a larger number, right? And in this case, if we look at the students who answered it incorrectly, who made the choice that 3.18 is a larger number, and we think, why did they make this choice, right? If you apply the whole number thinking idea here, you will say 327 and 318, right? Of course, then 3.27 is a larger number, but that's not what children are doing. What they're doing here is they're looking at the number from the reverse order. Now, what happens in a child's learning journey in mathematics? First, we teach them whole numbers, which is ones, 1, 2, 3, then hundreds, thousands, and all, right? Then at some point of time later, we introduce them to decimals. Now, when we taught them whole number, we are telling them that the order of the place value is ones, tens, hundreds, thousands, and so on. But when we are teaching them decimals, right, the order of the place value on the right-hand side of the decimal point is in the reverse order. It becomes tens, hundreds, thousands, and so on. Now, this distinction is something that many students get confused, have a confusion on, right? And when they have a confusion and a lack of clear understanding of this, then they start looking at the number from the reverse, right? And so they're looking at comparing 3.18, the 8, the hundreds of the 8, and the hundreds of the 7, and then they say that 3.18 is the larger number, and this kind of thinking is called the reverse order thinking. Take another pair of decimal numbers, right? 3.27 and 3.39. Now, again, here we know 3.39 is the larger number, but here some students chose the other one, which is 3.27. Now, if you apply the whole number thinking, 3.39 should be the answer. If you apply the reverse order thinking, even then 3.39 will be the answer. But then here students are doing something very different, right? They are extending their understanding of what they learn in fractions into decimals. Now this is called overgeneralization, right? In fractions, what do we teach? We teach them if you have half a pizza as compared to if you have a quarter of a pizza, you have more amount of pizza in half, which is 1 by 2, than in a quarter, which is 1 by 4. Which means that if your denominator is a smaller number, the portion size is a larger size, right? Now, when they're looking at 3.27, they're looking at it as 3 1 by 27, or the 0.27 is 1 by 27, and the 0.39 is 1 by 39. And they say that, okay, I have the 27, the denominator is a smaller number, and hence that should be the larger one. And hence 3.27 is a larger number. Now, this is what research calls as reciprocal thinking. Now, what we saw here is we asked 3 questions, right? Like one question with 3 pairs of decimals. The question was pretty simple. Choose a larger number, right? And we had 3 pairs of decimals. And in all these 3 cases, we saw wrong answers. But the reasons for the wrong answers are very different. Now, if we as an educator or any PAL program doesn't go into the details of why is a student answering incorrectly and simply gives another practice worksheet of 20 questions on comparison of decimals, it's not going to help the student, right? And this is where the individual tutoring becomes extremely effective, when it is able to understand, when it is built on top of the research of how students think, what kind of mistakes they make, right? And so how can I both be effective in diagnosing those mistakes and creating a remedial action once the mistake has been diagnosed or the misconception has been diagnosed. Now at EI, MindSpark is our personalized learning software. It is the PAL program that we run within EI, right? Now, what makes MindSpark effective is its ability to diagnose these incorrect notions or common errors that students make or misconceptions, and then provide a remedial action only to those students who need these remedial actions. And it's not any general remedial action that you provide, like I'm giving a practice worksheet of 20 questions on decimal comparison, but very specifically targeting the incorrect notion that the student is having and then providing a specific remedial action on top of it. And this is how it enables differentiated learning. This is one of the ways in which it is enabling differentiated learning, right? Another example that all of us are familiar with is the scale pencil example that we normally talk about when we talk about asset, right? Now, it's a very simple question on measurement. This question simply asks, what is the length of this particular pencil, right? And questions like these are pretty common that teachers ask in the classroom. But what is making this question, simple question, extremely powerful is the position at which the pencil is starting on the scale. Right? This simple offset of the pencil helps us uncover the misconception or the way students are thinking about measurement. We saw in those videos that students were actually counting the markings on the scale as compared to looking at the distance between the marking as unit of measurement. Right? Now, what MindSpark does is it's built on a strong foundation of data that is coming from asset. And this data tells us about what are the misconceptions that students have in different topics, in different subjects across grades, right? And along with this data, we've done qualitative research inside classrooms by asking students why they think or how they answer a particular question to uncover their thought process. So both of these have become solid foundation to build the content in MindSpark, which helps in increasing its ability to diagnose for these kind of misconceptions. And once it diagnoses, there is content in MindSpark to help remediate or help accentuate the learning for the student, thereby differentiating it. And another aspect I think that is useful for us to look at this point in time is when we look at building MindSpark or when we're designing MindSpark, we always look at it as a tool for the teacher rather than it being the teacher itself. Right? We never are looking at it as something that will replace a teacher in the classroom. We see a lot of need for both the human kind of a teacher doing instruction in the classroom, helping the students not only with the topics, but bringing in that human connect that enables motivation, that brings in a lot of element of learning. And then MindSpark being this assistant teacher, if she had to clone herself for 30 students, then that's what we would call MindSpark. Right? And that MindSpark then helps in reinforcing, diagnosing the gaps, addressing these gaps, helping a student move ahead, and for the teacher not to limit herself at leveling her instructions to the average level of the classroom.